black throne I keep on repeat. A derelict cathartic something from the ashes. The puppet master congregates all the masses, pulling strings, twisting minds as blades hit. You want this power, then come try and take it.
Yeah, long time since it's been a coding stream. And not just a coding stream, a GLSL path tracing stream. It's a black screen. 1 second. There we go. Okay. So I've done a lot of path tracers. Like a lot of path tracers. I should go on Shader Toy to show off. Oh, Shader Toy is not gonna load, is it? It's been a long time since I've been on Shader Toy as well, because part of the reason is because of how long it takes Shader Toy to load. Alright, well, if Shader Toy loaded, I would show you that the last, you know what, maybe I can load just the path tracing shader. Oh, yes, okay, it loaded. Alright, so this is the last, what I mean by universal path tracing shader is I mean, it's got a system in place where you can just, if you look at the code, you can define a scene. So this isn't just ray marking. This supports both ray marking and just regular analytic ray tracing. So like it lets you trace objects like ray plane, all these things, and then lets you set materials. And so this works pretty well. This approach, I actually love this approach. It's way faster if you split ray marked objects into separate objects, because it lets you do bounding boxes. So if you look at this RTC macro I have here that's just ray trace, it actually has a bounding sphere, so it does culling. It's so much better than, I just realized my camera and stuff is out of. Anyways, it's way faster, and I really liked this approach of splitting it up because it lets you mix ray marking and regular like analytic ray tracing. But, oh yeah, and if you see here, it supports transparency, but the way it does transparency in this, and the way it does like this cloud volume, so the caustics and refraction in this ray tracing system aren't proper either. So okay, this is really complicated, but so basically the way refraction is supposed to work is when you go into the object, you have one refraction index like this, and when you have a ray that's leaving the object, like say going out of this prism, then you would do like 1 divided by, you would do an inverted refraction index. That's the proper way to do refraction. It doesn't do that in this system because there's no volumes. It's just ray tracing objects. So the refraction actually isn't proper. It looks good, and it supports like full caustics and refractions, but it's not actual proper refraction. And then this volume, this cloud here, wait, there we go. Why can't, wait, is the mouse, why is the mouse movement changed? Did they change how like the mouse works or something? I'm confused. This is weird. Mouse dragging doesn't work all of a sudden. Dude, my shaders are getting broken. .w bigger than ZW is click. Why isn't it? What? Oh my god, did they actually break part of the site? It would not surprise me. It would not surprise me at all. There's a reason I've kind of stopped using that. Is only -1 for 1 frame. Okay. God damn it. Why would they... Wait, I'm so confused. Now it's constantly returning true even though I'm not clicking it? Is it just broken? What? Z to Y. No, it's there's no way to get the same effect. It's imos.w everywhere. It is imos.w everywhere. Yeah, hold on, let me go to the Shader Toy unofficial blog. I think that's run by Fabrice. I'm sure this covers it if it did change. October 14. No, it didn't talk about it here. Well, you know what? I'm not going to spend a lot of time on this. I guess this is broken. Alright, I guess it's fixed now. So I guess Z works. Alright, I guess Z does work. Man, that annoys the hell out of me though, how they just changed that stuff. I'm sure they announced it somewhere, right? No, no, that doesn't have anything about it. Classic. Alright, anyways, the whole reason I'm showing this shader is that this looks good, but this isn't proper volumetrics. You have no control over anisotropy and wow, you found it first. I'm not surprised about that though. You're pretty active in the Discord. Oh. Oh, yeah, this is talking about it. Old J is mentioning it. Alright, anyways, this isn't a good volumetric. The way I do it is I've got this volume here, and hold on, let me figure out where I have this. Alright, I've got this volume macro, and all this does is dither the distance function, which causes the ray to randomly step into it, which gives the effect of this volume or transparency. The issue with this is it doesn't cover the refraction element either, which basically means if you make it completely see-through, it's just like completely see-through. There's like, for example, there's volumes where the ray can go basically completely through, but it like bends the light. For example, like heat or flame can like just kind of bend the light or refract it. There's like so many things where just that refraction element happens. But you can see here, all that happens when you make it more dense is it just becomes less see-through. It's literally just like the literal sense of alpha, where you can see here it just becomes not see-through, which is fine. That works okay. It's still a volume in that like you can go inside and it actually gives you the effect of like being kind of in smoke. But yeah, it's missing a bunch of stuff. So what I've been trying to do for a long time, and what I think I finally figured out, is how to combine this volume tracing and how to combine the like refraction tracing. And it requires using sine distance functions, keeping track of inside if you're inside the surface or whatever. And yeah, so let's get started on it. I already have part of the code here. I'm not going to be using shader toys. I've talked about before. The site has a whole bunch of issues. I'm using my own program called Shader View. Download off the website. It's actually linked below in the information on my Twitch. So this is the most recent path tracer I've been working on, and I've already had it set up with a refraction test, but this basically did the same thing as last time, dithering the distance function. I've figured out that I need to put opacity or the transparency actually built in to the material here, and that way I can also build in refraction and all of that. So anyways, let me set up the test I already have. So I have this second shader here. that I used to call Path Tracer 1, but it really should be called Display Path Tracer. All it does is take the result of the first buffer and apply gamma correct and divide by the number of frames that have been traced, which is key for displaying a path tracer correctly. And then I'm just going to load in the shader. I think I actually have the refraction test set up as an animation. Yeah, okay. Yeah, so it's set to fly up and down through this grid of spheres. I'm just gonna take it and make it a single sphere just for testing. And I'm gonna turn off the animation. So we actually did this a while back on stream. This was the This is actually a path tracer that I removed a bunch of features from. I used to have this set up as a deferred path tracer. I think it's like right here. DPT. And I did a few different ones like that. The Underground Shrine. Honestly, it wasn't that great. I didn't make that great scenes in it. I did start working on my new logo though. Do I still have it? I should still have that somewhere here. I want to finish that eventually. But that's the thing. I want to get a nice... Every time I keep making these scenes in the sign distance fields, I'm not happy with the way it's path tracing. I'm like missing material features. Or specifically what I kind of want to do for this winter is make like a little winter scene with refractive ice and potentially try to tackle snow, which is actually a huge thing. Snow seems simple, but it's really complicated because it's made up of a whole bunch of tiny parts. What the hell? This just got bigger than my whole screen. God damn it. How do I even... Alright, here we go. This way we can view the shader and the code at the same time. Yeah, it's gedit, it's GTK3. This is the text editor that comes with Linux. Alright, so here's a refractive sphere. Actually not refractive, sorry, this is a volumetric sphere. But it has the same effect as before, where if I just lower the alpha, it basically just becomes see-through, it has no refraction, like that. So that's what I'm going to be trying to fix, is make this refractive. You're going Windows confused? Yeah, I just like it better. I like it better. Alright, So I'm going to redesign this material system. Currently I'm just stacking all the material values into a matrix, which, I mean, it works pretty nice. It lets me just pass around a bunch of values really quickly. So let's see, mat 0 color, mat 1x roughness. Maybe I need to turn this into... Wait, is a 2x4 matrix a thing? Or maybe a 3x3. I actually can't remember what GLSL matrix sizes there are. Wait a minute. Why is this only listing mat 3 and not mat 2x3? Wait. You need an extension for this? Are you kidding me? Wait. What? Alright, I guess I'm just gonna use mat 3, but like... What? Does that mean AMD doesn't have mat 2x3? I swear to God, it has to. 2x3. I'm thinking the wiki just doesn't list it and it's an actual thing. Hold on. GLSL 3 spec. Not G... Okay, here we go. 3.3. Okay, yeah. 3.3 has 2x3. Does WebGL... Okay. Yeah, WebGL 2 has mat 2x3. Alright, that's... you know what? I just want to be aware about that stuff because I am putting all my shaders on ShaderToy. Even though the website's super slow, they're still on there. Okay. So mat 0's color... I guess maybe I'll make number 2 opacity and refraction index. I'm just thinking if there's any other... Oh, I think maybe I could have anisotropy as well. Yeah, I don't know. I feel like... Oh, I can have 2 different roughnesses as well. I could have forward roughness and backward roughness. Alright, Nomori, I'll see you later. Have a good one. So this is the checkerboard floor material. It's got 0.5 roughness. Now I've got to decide what I want to make the material for this sphere like. I think I'm just going to make it shiny, and I guess I want to test the reflection, so I think I'm just going to make it mostly see-through, but with refraction. What do I want the refraction index to be? I can't remember if it's supposed to be positive or negative. I think, or sorry, above 1 or below 1. I think it's supposed to be above 1. Alright. Now, we don't do any of these opacity macros anymore. Instead, the opacity is going to be automatically handled in our material code right here when it does the path tracing. Oh, nice. And I had this value here, this global value, to disable the opacity so that it didn't blur the normals when it was sampling normals here. So we can disable this now, which makes the code a lot cleaner and nice. I like that. Oh my god, I just realized I might need to change this tangent in binormal too if I want to port it to GLSL 2, but whatever. Whatever. So do we always add emission when it hits the object? I think when it refracts, I should actually tint it. I think I should also actually have a tint color. Like, I think I'm actually supposed to multiply the color. I need to think about how the volume tracing will work in this sense. Actually, I should probably do the volume tracing before I do. So the volume tracing is going to require returning negative distances. So then, when the opacity is below 1, it'll have a chance to step into the surface where there's a negative distance. So, if it's already in the surface, and there's volume, and it hits the surface, does it scatter it, or does it refract it? Huh. Okay, so I think I measure how long the surface or how long the ray is inside the volume, and I multiply it by the color of the volume when it leaves, based off of how much it's inside. And then that should tint it darker when it traces farther through. I think I'm just going to start with refraction. So I need some way of keeping track that we're inside a surface. How if I want to just do it with a bool? Wait, it should actually be based off of opacity. Okay. So inside here is going to store how long it actually traces. So now down here when it's doing random, instead of reflecting, sometimes I need to refract based off of the opacity. Oh, and this roughness actually needs to change based whether or not it's inside or outside, but I'll do that afterwards. Just I'm trying to plan all this stuff out as I go. Alright. So if it's smaller than, then it's going to refract and go inside. Now it's going to reflect. I'm just thinking if I need to store anything. So this actually backs up the ray. We're actually going to need to push it forward. Y gives us the refraction index. And then I need to keep track of if we're inside. Okay, so I should do, here I should at least do inside equals epsilon times 4. Inside bigger than 0. Then we do backward roughness. inside bigger than 0. Wait a minute. I might need to flip the normal. Yeah, this will actually make it go outside the sphere. Maybe. That might actually not necessarily be a bad thing. Alright, if inside... I'll just do another if statement just to begin, just because it's so much easier. Then inside equals 0, and then we do inverted refraction. And I think I might have to flip the normal, but we'll see. Let's try this. Okay. That looks kind of broken. So that's it, completely reflective. Now let me try turning the opacity down. Let's make it invisible. Alright, and let's turn off the refraction. No, that's bending it even with the refraction turned off. Is it maybe because of this, where it's stepping backwards, or what? Alright, let's step through this. So, gets close to the surface. This returns true because it's 0, so it will basically always be smaller. Inside equals epsilon times 4. So inside becomes true. This might actually not step far enough away. So this backs up. Let me try increasing this to see if it's not stepping through the initial surface. No, I don't think that's it. It's still bending the ray here as well. If I make this negative, so it's never positive as well. And I'm going to increase the number of steps, so there we go. So yeah, you can actually see from that shadow back there that that is definitely a solid sphere. So something about that opacity isn't working. It either isn't stepping through, or Maybe it's not going negative. No, it's definitely going negative. So then inside the sphere, the geometry, the distance should go negative. Absolute should push it to positive, but it shouldn't be under the epsilon because it should be pushed through that. It should keep moving forward without issue, and then it should get to inside right here, which, oh, that might be what's happening, is it hits inside, it doesn't get pushed far enough outside so that it reflects again. No, that wasn't it. I wonder if there's a way of marking that it refracted. I guess I could multiply this to make it green. Okay, interesting. This is where it refracts. It's not refracting here for some reason. That doesn't really make sense. Oh my god. Oh my god, it does make sense. It does make sense. My material function isn't correct. It's not matching up with the floor. So the bottom half, oh my god. It is working. It is transparent. It's just, I had the bottom half of the sphere as the checkerboard material. Genius. Okay, let's... Okay, so that's the bug I was talking about, where it doesn't jump far enough ahead. Gets stuck. Maybe the answer is to push it based off the normal. No, that didn't do it either. Oh, that has an interesting effect. Why does it work backwards? That doesn't make much sense. Alright, so I can choose how much I want it to step forward. That is almost working. I think maybe times 10 is a good amount. Yeah, that works pretty well. Alright, now let's try it with refraction. How does the first step of refraction look? That looks like it's actually kind of working. I think now it actually needs the outer refraction to function properly. Let's try making the refraction index 1. Alright, hold on. I actually want to try to fix this around the edges. It's actually it not stepping far enough. Hold on, I want to opacity step. It's going to be the scale at which it steps through, so I can alter this. So I think just increasing that will fix my issue. I'm thinking I can increase it more the more perpendicular the normal is to the ray direction, or parallel. Let me just see, does this break when I flip the normal? Yes, it does. Okay, nice. So I have this correct. So now I'm going to split these into a base skip and a maximum skip, which is going to be done when it's sideways to the normal. Huh. So the issue is I actually need to compare kind of the tangent and the binormal. Actually, wait, never mind. I can do abs dot ray direction normal. So then when the ray direction is facing the normal, it will do the base step, and when it's facing the other direction of the normal, it does the max step. Okay. Not sure if it's skipping too much there or what's happening. Oh, this isn't being multiplied by epsilon. So that should be normal. Now if we increase that to 100, that's a bit nicer. But it has that issue there. So yeah, I feel like there's no good way. I feel like there's no good way of solving that besides just reducing the precision. Huh. I just realized this doesn't even need to be a signed distance field. I can just keep track of it going in or out. Oh my god. So that looks pretty good. I think I'm just going to make it a constant skip. Now if I just move that a little bit off the surface so that it doesn't have that clipping into the floor. I could also detect here if it's even a transparent surface. If so, I could just like disable the inside. That might actually fix that issue. Let me see. No, it still hits that and then does a step through. Okay. So yeah, that's the issue. If the opacity causes it to step ahead, then it does stuff like stepping through the ground. So I'm not sure how you would fix that. Like stepping ahead without also stepping through. I'm thinking if I disable this, it'll get stuck. Yeah, so there it doesn't show it going through the ground. shows sky. I'm thinking there's no way to stop it from jumping through another object. Or I think I actually need to just do this. Based off if it actually flips signs. Then I wouldn't even need to keep, well, I actually still would need to keep track of it being inside, but let me try that. What if distance smaller than distance bigger than 0. So let's just do if distance smaller than 0. So then we add up how far we're inside. And then here, if it is inside, then we reset that, and we don't need to do anything because it's already gone outside of the surface. See, this is difficult actually, because it's no longer just doing it based off whether or not we're on the outside of the surface. Doing it based off of whether or not it flips positive or negative, like it's in or outside. So we can't just check if we're within a threshold. I literally need to trace until it changes sign. See, this is the issue with doing volumetrics and refraction properly. It's really complicated. But I really want proper refraction, so. So this will actually work properly for the outside tracing. I just need to limit this to the epsilon. But in here, I might actually need to trace it into the surface. But that's the issue, it might never go into the surface, and then I might actually need to go back. Yeah, I guess I'm just gonna have to deal with it having the probability of hitting the surface again. Let's see if this... Wait. What's it doing here? Let's try turning off the refraction. Oh, it's still skipping into the surface. Huh. patting my cat. I'm just thinking, how do I trace step by step without skipping like that? And how do I integrate it into the main loop without adding a whole bunch of if statements or code that does like a separate loop? Yeah, I'm just realizing this actually isn't going to have the same effect as volume. Huh. I still need to plan this out more. Hold on, I'm going to go and get some water. Alright. I got a somewhat decent idea now of how to combine it. I don't think I need to track the inside. All I need is whether or not the distance is negative or positive. So even if it's smaller than or equal to epsilon, it's going to do the volume tracing. And so this is actually going to apply refraction over time and over steps. I'm not certain how much of an effect that's going to have, but we'll see. Yeah, I might actually need to trace or keep track of whether or not it's inside. Okay, so this might not produce proper refraction, but it should look good, and it should have both the refraction and volumetric effects. This is actually not needed if it's going to be tracing through. So this steps the ray forward, and this won't do any refraction. This should just kind of simulate what the opacity macros do here. So I feel like this is all overkill. It's just going to do the refraction there. I'm thinking if there's a way I can do this similar method to before, where I do the opacity dither here in the distance function, but then I still have the refraction here. But really there's no way to do that because I need to keep track of if it's refracting to do that. Oh yeah, and I'll need to find a different way to do backwards roughness here. Oh yeah, I might actually need to calculate whether or not it's refracting up here before I actually do the roughness if I want these separate ones. Okay. You know what? This is actually working okay. Boom. There we go. Oh my god. So there's the volumetric. If I make it much lower opacity, you'll see it's a volume. Oh, that's very nice. That actually gives the full, it's kind of hard to see, but you can see here the light actually makes a cone shape. This is because the reflection actually goes into the surface. Like, it's actually getting smaller when it goes to the center of the sphere. That's very nice. So now, refraction should be right around the corner here. So what happened there? I don't think... Oh, is that the little bit of roughness there is propagating? It's got one refraction, so it actually shouldn't be refracting. So what is it doing here? Is this just the surface being warped? I need to do... Oh! Ooh. I actually might want to do absolute geometry here. I see what's happening. The surface is incorrect. Or at least it looks like it. So let me think about this. The normal will stay the same even when it's inside the surface. Is it because it's reflecting inside the surface? So maybe if the distance is just smaller than 0, we don't even check for opacity anymore. No, that's gonna break the volume. Yeah, that just broke the volumes. Hey, Twig. What if I flipped both of these? Flipped it and then flipped it back. No, that still doesn't do it. So I'm thinking the vectors are flipped somewhere here. Alright, you know what? I shouldn't be doing this with surface actually to debug. I should just do it with the direct normal. No, it gives the same effect. So this, I believe, right here is the same effect as reflection. Yeah. So all it's doing is reflecting here. So what is it doing when it's not reflecting? Why is it causing this weird... Shouldn't a refraction index of 1 not refract anything like this? Wait. Okay, that flips it. I could have sworn that a refraction index of 1 has no refraction. Let me look this up, 1 second. Yeah, vacuum has a refractive index of 1, yeah. Let me look specifically at how the GLSL refraction function. I know how this works, I believe. Yeah, 1 minus the dot product. Maybe it's not normalized? No. It's definitely normalized. Okay, hold on. Let me test this on the complete ray here, because I probably just don't understand how the refract function works. So let's just pass the ray direction through something that's relative, like maybe just a flat plane. Refraction index of 1. So is this gonna flip the screen? No, that turned it around. I'm so confused. So as long as the refraction index of 1, it's exactly the same. So I think my normal is messed up here, is what's happening. Maybe I need to normalize this. Huh. What if I flip the normal and then flip this? So I feel like that should almost be correct. What is happening here? So the opacity is 0. So this is true basically every time. The distance becomes epsilon times opacity skip. My rubber duck debugging isn't solving anything. I'm just trying to figure out why would the refract function even change the ray direction with a refraction index of 1. It doesn't make sense. At least with how I understand the refract function. So yeah, it's definitely flipping it here and doing a refraction. You know what's happening. It's supposed to get refracted back. Nope. Oh my god. What is happening? I'm almost at the... You know what? Alright, I'm just gonna debug the ray direction. Let's just see exactly what's happening. So... what I'm gonna do is I'm gonna output to the emission the ray direction, or set C and L. Actually, set C to 1 and L to the ray direction. And breaking. So this should give us around our sphere. Where is it converting? Oh, never mind. I need to do the color right here. And I'll just set the emission to be 1. So this should make the sphere colorful red and blue. Turned completely black. That's not what I was talking about. C equals this times equal that. Huh. There we go. Wait, why does doing this... why did doing that break it? I guess it just didn't load in the code correctly? Okay. Anyways, this is our ray direction. Pretty simple. We're just going to see how this changes when we refract it. What the hell? It didn't change. What? Wait, what? It's being displayed as exactly the same. I am confused. This doesn't make sense. If it's exactly the same, then why is it literally giving a different result? This doesn't make sense. It actually just doesn't make sense. Maybe it only does it when it's negative. So let's only back out when it's actually gone into the surface. Oh my god, this might actually make perfect sense. It refracts properly right at the beginning. No, this is still showing the same thing. What the hell? What is even happening? No, this still doesn't make sense. Maybe I'll isolate them. Make it so it only displays the Z. Now let's make sure these are the same. Yep, those are both the same. That's the same. And that's the same. Alright, let's do this exactly. Let's check what is the difference between the two. Alright, it's still not showing any difference, so this should output... Oh, this green spot here is actually the difference I'm talking about here. So if it is different, is refracting differently, it'll output some color, either like green, red, or blue, in a very strong color, because it's times 1,000. So it's showing up down there, but nowhere else. Maybe I need to go a little bit more into the surface. No, that still doesn't make sense. It's still functioning correctly, except for right there. So this doesn't make sense. If it is refracting correctly, then why is it changing? This doesn't make any sense. What? How is it equal but different? It must be doing it like right at the end or something, right as it like leaves the sphere or something like that. I can't figure it out. Alright, I got one try. Alright, flip these by the dot product of the ray direction and normal, so that if they're facing different directions, it flips the normal. Oh my god, it worked. Okay, so now, presuming everything is actually working as it should, this should refract. Okay, one thing at a time. Let's try with a tiny little refraction to begin. So what is happening there? And why is it wobbly? I wonder if that is the opacity skip. Because it skips a constant amount, I might need to make it skip a random amount. Why does this break the refraction? Do I need to normalize it or something? Wait. What? I actually did need to normalize it. No, these will have both the same effect. So what is happening here? Let's try increasing the skip amount. I think that works. It's hard to tell. It might actually be skipping too far. And going into the ground, but I'm not certain. Yeah, like I have a feeling right here it might be, but when it's doing small steps like this, let's just try to turn up quality on the ray tracer and get things working. So I wonder if the refraction here bends it so that it never hits the surface. I might actually need to code it so that it only does the refraction once, and then when it's inside the surface, it doesn't do the refraction anymore. Yeah, I feel like it's actually making the ray like orbit in circles, doing the refraction like that. So let's try just doing the refraction when the distance is bigger than 0. That's looking a bit better. Nice. Okay, so that is somewhat proper refraction. Now it needs to, yeah, so to actually get it working properly, I need to flip it in and out. So when it's positive like this, I do the one refraction, and then when it's leaving, I do the flipped refraction. I'm just thinking, let me try something. Inside. So if we step inside, then we'll do inside equals true. And then if inside and distance bigger than 0, so this means we step out. Then this means we're going to refract. Okay, so actually I'm going to do this in a separate if inside and distance bigger than 0. Then we'll set inside to false. And this way we can just do if not inside. Actually, this won't handle volumes correctly. Wow. So I actually can't figure out how you would combine refraction and the volumetrics, at least in like one universal system. Let me try to get the proper refraction though. Okay. Maybe I do need to do this multiplication. Alright, let's see how this functions. Oh, no, I think the refraction's broken. Maybe. It looks just like before, but it should be doing it differently because it should actually step. Should do it differently when it steps outside. Yeah, so I think maybe the solution without tracking inside is the best I'm going to get right now. Or is what I'm going to be happy with for now. I'm really just looking for something where I can get both volumetric and refractive effects. Does it work though is the question. So with slight bits of a refraction like that, it works. So right there it gets total internal refraction around the edges, which actually isn't proper. I'm actually trying to figure out a way to get rid of that, but I don't know. I think I'm just going to need to deal with inverted refraction for now. So yeah, even with the inverted refraction, you end up getting total internal refraction, like this, where it eventually only bounces around inside the sphere. Honestly, not really sure what you can do about that. So that flips it mostly upside down. I still feel like this refraction could be a lot better. Let me try and just generally increasing the precision. Yeah, I feel like the refraction and volumetrics just are not designed to go together. It's just like completely different things. You know, I almost feel like that path tracer I have on Shader Toy is like the best I'm gonna get, because honestly it does let you handle that. Let me look at that shader again. How do I do refraction here? I swear to God, it's just the super simple. If opacity, refraction index. Back up by normal. It's pretty much the same. So let me see, this doesn't have volume tracing, does it? Yeah, so this is pretty much the same. Huh. I am really surprised it's not working. I think the main difference is just that I have this volume code here. Yeah, so that's still not proper refraction. Huh. What is redo again? Alright, I think I'm going to try to go for proper refraction. I guess tracking the inside is like all I can do in that sense. See, this still bugs me though, because this isn't going to get the volumetric refraction. Or, sorry, it's not even going to get like the volumetric scattering. Alright, I'm going to go get some water and stretch. I need to think about this. I still don't have, like, yeah, I still don't have a plan of how I can actually get both of these effects together. Alright, I'm actually gonna try the idea I had before again. I am gonna try the volumetric stepping. I'm thinking, what if I toggle this when the normal direction flips? So even the slightest refraction rate, yeah, should cause major bending and effects in this because it's repeated over and over again. But I'm thinking, what if when you're partway through, what if I invert this whenever I invert this sign? So it's bigger than 0, that. And when it's smaller than, divided by. Interesting. It's just slowly turning opaque. It's not doing transparency. Let's try it the other way. No, it's just not working. What about with a bigger opacity skip? Huh. I'm almost thinking I need to make the refraction and volume completely separate. Alright, well, this obviously isn't going to work. So what's my next plan? I'm really determined to try to get the proper refraction working one way or the other. But I don't want to have just refraction. When it goes through the inside of the volume, it should like get darker due to the volumetric, and it should potentially like blur the things behind it due to the volumetric scattering. But yeah, to combine those, how do I I definitely think I need to do something that detects the surface and does refraction on the surface. But then that's the thing, how do I cause the volumetric scattering? I mean, I feel like the refraction is the proper way to do the volumetric scattering. So maybe I'm not supposed to flip the normal sign. Yep, I think I'm gonna have to go with just crappy refraction. Or incorrect refraction. Oh my god, now it's not even working. Or it probably is. It's probably just my opacity skip. Yeah, oh my god, so is it just not making it through? I really feel like the opacity might be better because it lets you control how much it skips. So you can make it go way faster. So the refraction might have actually been working. It just wasn't going through. I almost feel like I need to make a version that is specifically for refraction. I might make the camera rotate around so that I can see completely what refraction is happening. It's so weird to me how even with such a large opacity skip it still gets stuck inside. I wonder if it just continually bounces around the surface or what. It's actually quite interesting. Anyways, let me try spinning the camera. That's kind of right. That's weird. It's actually like the refractions are almost working, but not quite. Let me try easing into the refractions. Yeah, these weird lines show up. That's so weird. So it catches the sunlight. Yeah, these weird lines in the refraction. Yeah, I definitely need to do the refraction just based off the surface. So yeah, this volume, the distance dither for volumetrics works way better. So how could I combine that with refraction? even if it's just like doing refraction right on the surface and then doing the volume dither for the rest. I'm thinking I could do a volume dither on the inside, and then I could do a refractive sphere on the outside. I'm just thinking how... So the refraction would still conflict. The refraction would still need to be its own system, similar to the opacity here. I mean, Let's see how much history's in this thing. Can I just undo it all the way back to the beginning? Just undo all the work we did. Here we go. Okay, so I wanted to get back to when I had normal sampling. So actually the opacity here should be next. Yup. Okay. So now I need to decide, I guess opacity and refraction index will still be the same, and backward roughness will still be the same. And I'll do basically what I did there with a chance of refracting, except it'll only be designed to work with non-opaque objects. Alright, so there's my volumetric reflective sphere. So I actually don't need opacity for this. I just need the shell of the sphere. Alright, so that's reflective. And now hopefully we can implement the opacity and refraction right here. Separate things. So actually at the end of the day, this is exactly how I implemented it in the Monte Carlo path tracing here. Wait, actually, I have the opportunity now, though, to do the proper refraction and keep track of if we're inside the surface, and do the inverted or flipped refraction. So let's see, this should just go straight through. Oh yeah, I need to lower the material first. And need to make it completely see-through. Okay, there we go. So now this gives us our opportunity to test out the refraction. So far that looks like it works. Let's try a little bit either way, see how it reacts. Alright, so that looks good, except for the fact that it is incorrect refraction, and that it actually needs to flip the refraction index when it's going out. So inset or flip refraction. Wait. Do I want to reset this when it reflects? Whatever. Let's try it. So that looks a bit better. Kind of. I think that might actually be proper refraction. Let me look this up, hold on. No, that's not what I'm looking for. Although I feel like this is correct. Flip refraction. Maybe I need to flip the normal too. And this way I can actually control what way the refraction goes, so we can actually test if the refraction is only being applied to the back or front. So that actually looks pretty decent. That actually looks like refraction. Wait, did I just get it? Okay, now let me try forwards. No, that doesn't seem correct. Alright, let me just look up what some realistic refraction indexes are. I think glass is like 1.3. .5. I can't tell if this is correct or not. Hold on. Oh my god, it actually flips it. Okay. Apparently glass balls or spheres actually do flip. So this is correct? Try spinning it around in a circle again. No, I guess this is correct. Okay. Complete refraction index just flips everything. Huh. Oh, there we go. It just requires a whole bunch of steps to not get the total internal refraction. Man, refraction is complicated. So let me actually see if this... If this gets full steps, then it's returning full background. Alright. So this should actually make it way darker around the edges. Yeah. Huh. Okay, so now this total internal refraction is actually going to destroy stuff in the rendering. Or like, not destroy stuff, but it's going to make the rendering look way worse, because the whole thing is, how do I have it fill in this without doing like 250 steps? Or doing like a giant refraction skip size. I'm wondering if it's like a probability thing, where I have it take massive steps every once in a while to potentially get it out, to make it like break out of this total internal refraction. Huh. I definitely think there's a way to fix that. I just need to think of it. Either way, I'm really happy to have proper refraction in here. And this is cool because you can actually see it focusing the light from the sun. Caustics. Ah, yeah. But yeah, how do I break this total internal refraction? obviously do a massive number of steps. I mean, this actually might be just going to the sky. That's the thing. Is this border here just going up to the sky? I guess I could do a could do a double plane here. Wait, what am I? How do I do this? Abs -1. Wait. Oh, that's doing a glass plane up above. Hold on. Got y smaller than 1. No, yeah, it is. It is definitely just getting total internal refraction right there. Okay, let me try one more thing to test this. Instead of doubling up the plane, what if I limit it to a specific area? So that I know it goes to sky. And then, yeah, we've got the 250 steps. And then I can take this away so it returns black. Yeah, so you can actually see in the borders here where it goes into total internal refraction. So now the question is, how do I break that? How do I break out of that total internal refraction? I could just do a massive step size, but that lowers the quality a lot. So what is it like? Okay, I'm thinking a solution similar to the opacity where you choose a skip distance, or it randomly applies that skip distance based off of a random value. So that way it doesn't lose as much quality because it does it in non-fixed steps. But then there's the other thing of like, I almost need to have it so that most of the time it does a small step size because that's all that needed. It's needed. Oh man, you know what I actually need? I need some way to detect the total internal refraction. Like, how could I easily detect that the ray is getting stuck? I mean, maybe I could limit it so the ray can't go perpendicular to the surface. for now, I'll try doing the skip randomly. Let's just see if making it random has any difference. Okay, yeah, that's what I thought. I need at least a minimum skip. But yeah, that does nothing to solve the issue unless I increase the skip as well like that. Maybe as the number... Oh, I've got it. Wait, no, never mind. I can't count up the number of refractions because I have no sign in this method. Yeah, I think all I'm going to have to do is mess around with this skip distance and try to improve that. Like, I think this can look pretty good. I want to try to get it working with a low number of steps, though. So I'm going to try messing around with this probability and the rate at which it does it randomly. Like I was saying, I think you just sometimes need to make it jump these bigger distances. I'm going to go get some water, get up and stretch and think about that. This is so weird. It has enough skip to literally jump outside the sphere. Huh. Maybe it's like even something like this. I don't know. I actually don't know. I don't think there's any solution for this total internal refraction. Besides just like eventually making it just skip refracting. I gotta think about this. All I really need is some solution to fix up these black borders or something where there is total internal refraction. And at the end of the day, I don't want to do a massive step size of like 200 because that actually breaks a bunch of stuff and can cause it to step into the surface like down here. So doing a small refraction skip like this is actually super ideal for performance. But the question is then how to fix this like black border. I have a feeling this right here is the epsilon, and that by lowering the epsilon I can lower the border, but yeah, but there should be some way of eliminating that without it. And then eliminating that would also make it pretty easy to clear up that. I need to think about like how would you detect the scenario where it's at like a border like this or something. Okay, let me try not normalizing. It seems really stupid, but maybe. Okay, not normalizing actually fixed it a little bit up there, which is very interesting. I'm just thinking if there's a way I could potentially count up the flip refraction, but there isn't without the sign distance. me think about what's happening here. Distance smaller than or equal to epsilon. I wonder if the normal is actually being equal to 0 there. Could actually be a place where it's returning. N does not equal n. No. I do think the normal might be somewhat off there, though. That kind of fixed it. That looks better. Interesting. What is this doing where it's partially mixing the edges? Weird, so if it's too big of a skip, what is it doing? Okay, what if I flip refraction index based off the position in the material? Hold on, I might not even need to track the refraction here. I could maybe just flip it. Inside the material code here. So if length smaller than 1, no, that just has the same effect. Oh my god, never mind. That is way better. Whoa, that is way better. Okay. That is best by far. It still has the total internal refraction, but... Oh wait, is it not? It might not be flipping it though. Yeah, actually it's not flipping it properly. So like refraction of 1.5 should be flipping it, yeah. Actually, maybe that is correct. Maybe that was correct. So this way is partially better, but it doesn't seem to do this refraction properly. Yeah, that's weird. Or I guess it has the exact same effect. So that still doesn't solve the issue of how the hell do you stop this total internal refraction? I'm pretty happy with this so far, except for this damn total internal refraction. I feel like I'm not going to solve this now, and this is something I need to just like go and think about. Because I'm not sure what a solution for that would be. Like, it looks alright when it fades to the background like this, but you can pretty obviously tell that it's still cutting off right here. So something where it either like jumps through and just skips the refraction, so it just gives you a direct background, or something is better than this cutoff. Especially here, if it's not doing the background lighting. I don't want it cutting off at all like this. It's kind of hard to tell, but like there's a bit of cutoff here that's okay. I should actually turn this up a little bit just to, yeah. So this black border around the sphere, that's the total internal refraction I need to somehow fix. Overall though, I'm pretty happy with this, because this also should allow for outward roughness. Like I should be able to, yeah, just make it rough one way, so it's only rough viewing through the sphere. That's nice. Oh my god, wait a minute. Wait a minute. A tiny bit of roughness fixes the total internal refraction. Oh my god, hold on a second. Oh my god, a tiny bit of roughness fixes the total internal refraction. The fix was literally built into the ray tracer already. I just needed to set the values right. Oh my god. Alright, so hold on, let's do a rendering. Oh yeah, that's beautiful. Well, there's our refraction. Very nice. Very, very nice. All right. Well, there we go. There's our refraction shader. I think I might be back tonight. I think I might. I said I was gonna make this. First of all, I said I'm gonna try to make a winter scene, but also I want to try to do snowflake rendering. Like basically try and create snowflakes by creating tiny little fractal shapes and then combining them into a big bunch of snow. I think it would be really slow, but I'm kind of attracted to doing that, to try and get good looking snow. And now that I have refraction and everything and volumes, it should be set to go. Alright. I feel like I might go and play a game for an hour on stream. Yeah, think about it. I'm playing a good amount of Spellbreak. I could also start Shadowrun. There's so many things to do. Yeah, I don't know. Gotta make dinner in like 40 minutes or so. So it wouldn't have that long, but I'm just sitting and just super happy that I got this refraction working proper. So the one I think the one effect I'd like in the path tracer now is depth of field, and that is actually pretty complicated, but like you basically distort the ray. Actually, you can distort the ray position. You can do it by distorting the ray position or direction. But I'm not going to worry about that now. Yeah, alright. I think that'll be it for the stream. Thank you for watching. It's been my first programming stream in a while, but I always really like doing these GLSL programming on these GLSL coding streams. Even though I can barely talk at the end of them, it's really visual programming, so I think it's good stuff to do on stream. And it's also something that I think not a lot of people do, so I do like to share it. Although, that's the awesome thing. Nowadays with ShaderToy, there are more and more and more people doing this online shader program, which is just awesome. Because you get so much more quality shaders and stuff to learn from as well. But alright, thank you for watching. I hope you enjoyed the stream. I'm on Discord or Twitter. Or I have an email too if you have any questions. See you around. I hope you have a good day, good night, good afternoon, wherever you are. Bye-bye.